Dear students, today we'll see the topic about self-induction. So in previous lecture we have discussed about Faraday's laws of EMI. So according to Lenz's law, how we have decided the direction of induced current also. So now we'll see the self-induction. Here let us consider a coil. This coil is connected to a battery through a tap key. This is the tap key and this battery is EMF is E. So this coil, so the coil is connected to a battery through a tap key. If the key is closed means the key is in on mode. So when the key is pressed or key is closed, the current starts growing in the circuit. When the key is pressed means this one. So current starts growing through the coil or a circuit. So current is growing means what about the magnetic field lines entering into this coil? This also it will be increase. So current is increasing, magnetic field lines linked with this coil also it will be increased. So magnetic field lines increasing means the flux is increasing. So flux is increasing means whenever the flux it will be changed, then which EMF it will be induced, that is we called induced EMF produced. So this induced EMF causes to produce induced current. So this is the direction of the current. And here the induced EMF and hence induced current also it will be produced in such a way that it opposes the growth of the current in the circuit. So here simple point, when the current starts growing, magnetic field lines linked with the coil also it will be increased, that leads to flux is increasing. When the flux is increasing, automatically the induced EMF it will be produced. So this induced EMF produced in such a way that it opposes the growth of the current in the circuit, because here in previous lectures already we have seen induced current or induced EMF produced in a conductor or a coil in such a way that it opposes always the change in the flux or opposes the cause to produce in it. So here what is the cause? Induced current, the current it is increasing. So current is increasing means the EMF induced in this coil in such a way that it opposes the growth of the current. Similarly, if the key is released means key is opening or off. So when the key is released, the current in the circuit starts decreasing. So now current starts decreasing. If the current starts decreasing, then what about the magnetic field lines linked with this? Also it will be decreased. Then flux also will be decreased. So again flux is changing. So flux changes always leads to produce induced EMF again. So this induced EMF produced in this coil in such a way that it opposes the decay of current. Decay of current means a decrease of current. Here two cases I am telling you. One is a key is pressed. When the key is pressed, here also current is increasing. Induced EMF it will be produced. This EMF it will be opposes the growth of the current. Similarly, when the key is released, so current starts to decrease. So again flux will be changed. Induced EMF will be produced. This induced EMF opposes the decay of current. Decay of current means decrease of current. So in both the cases, EMF is induced. That EMF is opposing the growth or decay of current. So this phenomenon we called self-induction. Here flux is changing means this is the flux is changing inside this circuit by itself. We are not taking any magnet to vary the magnetic field lines. Just we have taken the battery, it is connected to a coil. So here when the key is pressed or released, then current starts to either increasing or decreasing. According to that, the EMF it is induced by itself in the circuit. That's why it is called self induction. So here I will write the definition. Definition of self induction. It is the property of a coil by virtue of which it opposes the growth or decay of current flowing through it. Or in another way also we can define the phenomena of a coil, the phenomena of inducing EMF in a coil due to the flow of current which changes with time in the same coil. So these are the two definitions we can define. One definition is it is the property of the coil by virtue of which it opposes either the growth or decay of current flowing through it. Decay means here decrease of current, remember it. So in another way also we can define it is the phenomenon of inducing EMF in a coil when the EMF is induced due to the flow of current. This flow of current it may be increase or decrease. So whether it is increases or decreases, the EMF it will be induced in the coil. So what about if the current is steady? Means current flowing through the coil it is constant, then there is no EMF induced in that coil. So there is no self induction process in that case. So what is a self induction? Whenever the current is grows or current it will be decrease in the coil or in the circuit, the EMF it will be induced in it. The EMF induced in such a way that it opposes the growth of the current or decay of current in the circuit. So here now we'll see that coefficient of self induction. It is denoted by capital L, or we can call self inductance of a coil. So both terms are same, coefficient of self induction or self inductance of a coil. So here in this circuit, so when the key is pressed, the current I flows through the circuit at any instant, let it be I. At any instant the current flowing through the circuit it will be I. So due to this I, the flux linked with the coil it will be phi. So it was experimentally found that there is a relation between this magnitude of the current and the flux linked with the coil. So it was experimentally found that the magnetic flux linked with the coil at any instant is directly proportional to the current passing through the coil. That is, we can write phi is directly proportional to I. This is an important point. So the magnetic flux linked with the coil always directly proportional to the amount of current flowing through that circuit or the coil. So phi is directly proportional to, if you remove the proportionality symbol, you can write phi is equal to L into I. Here L, where L is equal to coefficient of self induction. So here either coefficient of self induction is L, or the self inductance of the coil also we can call it. Suppose the current flowing through the coil is 1 ampere. If current flowing through the coil it is 1 ampere, then this equation becomes phi is equal to L. Means from this expression what we can call self inductance of the coil is numerically equal to the magnetic flux linked with the coil when the unit current flows through that coil. So here once again I will repeat, the self inductance of the coil is numerically equal to the magnetic flux linked with the coil when the current flows through the circuit. It is 1 ampere. So here already we have seen if the current is either increasing or decreasing, the induced EMF it will be produced. So here we are talking about a key is pressed. Key is pressed means, so here also EMF is induced. Now we'll see that